Now let's have a look at integral calculus. What is integration? Integration in calculus is simply calculating for area under a curve. If you have the curve y is equal to f of x as I have drawn, area under it, calculating for that area is what is termed as calculus. Calculus is a method used to calculate area under a curve. Now, if you want to calculate area under a curve, you divide the area under the curve into different rectangles with the same width, and the width of the triangle will be delta x. And the height, since it touches the circle, the height here will be the length of the rectangle, and that will be f of x. So to get the total area under the curve, you add the total number of rectangles, area of all the rectangles, and you get the total area under the curve. So if you have 1, 2, 3, 4, 5, 6, 7, 8 triangles and rectangles, you add all of them, or you calculate for one, then you multiply by 8, then you get the total area under the curve. But one significant thing that must be noted is that if you consider rectangles, these areas, shaded areas, are not included. So the accuracy of the area under the curve will not be attained unless you strategize it in such a manner that these areas will be included. In that case, you increase the number of rectangles. You see, you increase the number of rectangles as I've done here, so that all these shaded parts will be included. You see, it will cover everything. So as you increase the number of rectangles, then the accuracy of the area under the curve. Now, what is the area of a rectangle? Area of a rectangle is calculated by area is equal to length times breadth. But as you have increased the size, as you have increased the number of rectangles here, you see the width reduces. You see the width was like this, equal width, but now it has reduced. If you continue increasing the number of rectangles, then delta x will be approaching 0. It will be approaching 0 doesn't necessarily mean that it is 0. It will be approaching, it is getting to 0. Now, area of a rectangle will be equal to f of x times delta x. Because if you pick one rectangle, the height here is f of x, and the width is delta x. So it's length times breadth, which is area is equal to f of x times delta x. And now, what you have to understand as students of mathematics, that you have to sum all rectangles. So it will be summation of all the rectangles. Summation of I is equal to 1 up to n. What this means is that we are summing from the first triangle up to the nth, because we can have a number of them, a number of the rectangles. As we continue dividing it, the accuracy of the area. So f of it, f of x 1 times delta x 1. What means that this is this is a series. For the first triangle, then you can go to the second triangle, I is equal to 2, I is equal to 3, I is equal to 4, up to the nth one. So, and I've said that if you increase the number of rectangles, you see that the width becomes so small. The width becomes so small. It is approaching 0. So the limit, as n approaches infinity, delta x approaches 0. Summation I is equal to 1 up to n of f of x1 times delta x. This one, as n increases, that number delta x approaches 0. That's delta x approaches, because the width. But if you look at the size of the width here, you see, and this one, you see that this one, as you increase it becomes so much, delta x approaches 0. Then, although this is series, this can be summarized as integral, because the sum is written as integral, which is Lebanese notation, because calculus is credited to Lebanon and Isaac Newton. They brought calculus. The two together brought calculus. In fact, it is a legal, it became a tussle as to who should be credited with calculus. But Lebanon brought this notation, which means summation of f of x, because we are not talking about a particular one, dx times delta x, dx. Delta x is equal to, in mathematics calculus, delta x is equal to dx. But delta y is not equal to dy. So this is what you call integration. Integral of f of x dx. That is what you use to calculate for an area under a curve. This is indefinite integral. But the situation whereby you are given a certain range, let's say from this range A to this range B, or let's pick this range A, the range here A, to another range B here. You are calculating for area under a curve under this range within A here to B. That's why we call it definite integral, which is given as integral A to B f of x dx, because you have been given a specific range within which you must work. You must calculate the area under that particular curve, and that is what we call definite integral, because the range has been given, in fact, conspicuously outlined. Integration, on the other hand, can also be a method of calculating for a function whose gradient function has already been given. Let's have a look at it. If you have y is equal to f of x, if you have y is equal to f of x, then the differential function you differentiate will give you dy dx is equal to f prime of x. Then you multiply through by dx, you get dy is equal to f prime of x dx. Now, if you integrate both sides, if you integrate dy, you get y is equal to integral f prime of x dx. You understand that? And this is what you call integration. That is, you are calculating for the function whose gradient function has been given. And thank you very much for watching me. May God bless you. I am Hussein Abdul Razak. You can subscribe, like, and share.